This is Chapter 4, and Chapter 4 wants to review basic probability and statistics. Okay, so we will have the review for probability and statistics. Well, because we want to have the simulation for the probabilistic models. Therefore, we need to use probability. And we want to collect the measure. And based on the measure, we will have the performance. And that performance actually, we need to have some statistic. Well, for that one, therefore, we will have probability and statistics. And in the following, we want to know, we want to use them, right? Well, actually, it's part of simulation study, all right? Because we want to have the probabilistic models. Well, if we have probability and statistics, and of course, if you take the course, we ask you to form the team for the final report. Actually, each one you need to take care of these. However, if actually it's maybe this one covered by a team of a company, and then at least one of a person should take care of probability and statistics. Well, if we have these, of course, later we will know how to model a probabilistic system, and so that we can validate. Well, we want to understand, so of course we need to review, and later in Chapter 6 and Chapter 8, we will know how to have the modeling of a probabilistic system. All right. And such a system, in fact, we need to have the input probability distributions. Well, we need to use this. Of course, we need to understand probability theory. And later we will know we need to choose the distribution. If we need to choose the distribution, actually we need to set parameters. So how to do? Well, this chapter and Chapter 6 and 8, we will study these. Well, first actually we will have the collected data, and so that we will analyze the data. If we want to analyze data, we will rely on probability statistics. Right, we will rely on statistics. Well, because of this, of course, we need to review probability and statistics. Well, first, actually, we want to run simulation. For running simulation, we need to know the concept of random variables. Well, random variables, so data check random variables first. Well, originally, for probability, we should have an experiment, sample space. Well, based on experiment and sample space, then we will have the definition for some random variables. Well, experiment, in fact, we want to maybe investigate some phenomenon. So we need to have the experiment. All right. Based on the experiment, then we have the corresponding sample space because we want to observe some phenomena. So we will have possible outcomes. If we have the set to denote all possible outcomes, that set we call sample space. And for outcomes, actually, we can call their sample points. All right, so something like we want to know the following example, flipping a coin. And flipping a coin, of course, it's an experiment. And this experiment, we will have for the outcome head or tail. So for this example, we will have flipping a coin to have a head and tail. Right? Well, up to now, we have the experiment and sample space. And another example. Again, we have an experiment, and we want to know sample space. Well, tossing a die. Of course, we assume we have a 6-face die. All right, 6-face die. 6-face die, then we check values on top. For example, here we have 1, and it can be 1, 2 to 6. So of course, we have all possible outcomes here. And actually, these form the sample space, 1, 2, 3 to 6. Well, if you check head and tail, value 1 to 6, of course, for the original experiment, we may have numbers or we may have characteristics. Oh, here, in fact, we want to convert experiment or sample space to real number. All right, so if we want to convert outcomes to real numbers, or maybe some set of the outcome to a real number, then we will have the random variable. Actually, for us, we will feel random variable. Indeed, it's the random number. If you want to think so, that's okay. Well, but formally, we define random variable to be a function or a rule. This function or rule will assign, let's say, maybe part of subset, actually subset to a real number. Well, if so, then we have the random variable. For the random variable, we want to know number, and also we want to know probability. Well, if we have a probability, maybe we can convert the outcome to number so that we will have this x. X actually, it is the random variable. And this random variable lower than or equal to a specified value, x. In fact, we can find the probability. And so that we will have the probability associated with this event. Well, previously we have an experiment, sample space, and right now random variable. And in fact, we will have the outcome to have the event, but why? random variable lower than or equal to a given value, then it's an event. In fact, you can find some suitable point meet this inequality. If you can find those points, and those points form a set, actually it's a subset of the sample space. If it is a subset of the sample space, of course, it should be an event. Well, so this is event, and for this event, we can find probability. Well, if we have these outcomes, we will have the random variable, and random variable associated with the probability. Well, if we have a random variable, later we will have a category to have a discrete random variable, or category to have a continuous random variable. Well, if we have a real number, right? And based on real number, if we have the countable values, as for countable, actually finite is countable, or maybe countable infinite. If we have a countable infinite, for example, you can have 1, 2, 2, infinite. So this one, a natural number. If we can have a mapping to a natural number, then we can call it's countable infinite. Well, 1, 2, 3 to the others. Why we call if we can have the mapping? For example, you don't want to start from 1. Is it okay? Sure, you can start from 0, 1, 2, and the others. Actually, this one, through proper mapping, actually we can have the mapping to the natural number. Then this one is still countable. If we have a countable number of values, so countable will have a finite or countable infinite. If so, then we will have the discrete random variable, or otherwise uncountable. Right? Otherwise, uncountable infinite number of values, then we have continuous random variables. All right, so we will have discrete random variable and continuous random variable. Why we want to have the two sets? Actually, because of the following function. In fact, if we can have the two type of random variables, actually it will be easier to have the following discussion.